Today's topic is isochoric process, and this is one of the thermodynamic process. The isochoric process is a process in which volume remains constant. And from the ideal gas equation, which is PV equal to nRT, if volume is constant, n number of moles and R universal gas constant, these are same for a sample. Therefore, we can write pressure is proportional to the temperature for isochoric processes. Because volume is constant, so change in the volume will be zero, and because work is defined as the integral of PdV and change in volume is zero, therefore work will be zero. And from the first law of thermodynamics, we can say that the change in the heat will be equal to the change in the internal energy. One of the example of the isochoric process is the ideal gas contained into the rigid wall container. So for rigid wall container, the volume remains constant. Therefore, we can say ideal gas obey the law P proportional to T. Using the first law of thermodynamics, which is dq equal to du plus dw, heat equal to the change in internal energy plus work done, and we can write dq equal to du as dw equal to 0 for isochoric process, and du is defined as the change in internal energy is the number of moles multiplied by the molar heat capacity at constant volume and the temperature change. So we can say dq equal to du equal to ncv dt, where if we have to find the total heat, then we have to integrate this ncv dt, it gives the total heat, and that will be equal to ncv, because n and cv are constant, and integral of dt will give t, and integrating from the limit t1 to t2 we will get ncv t2 minus t1. Here we have to note some of the point that we have mentioned here this dv equal to 0. If we say dv equal delta v equal to 0, delta is a large difference, then process is not necessarily an isochoric process. The delta v equal to 0 will be an isochoric process if everywhere volume remains constant. In the isochoric process, because delta v equal to 0, we can say if heat is given, then dq is greater than 0, and because of the heat given, the internal energy will be greater than 0 because temperature increases. While if heat is taken out, as per convention, dq will be 0, and in that case temperature decreases, and hence du will be less than 0 or negative, because u is a function of the temperature. If we see the diagram, that is the indicator diagram or PV diagram, here PV diagram for the isochoric process shows a vertical line parallel to the pressure axis. So this line shows this volume is constant, and suppose A is the initial point as mentioned here and B is the final point, then in this process the change in volume is 0, and hence work is equal to integral P dV, that will also 0. Let's take one of the question. Question is the temperature of 3000 gram of gas is raised from minus 20 degrees Celsius to 75 degrees Celsius. This is 75 at constant volume. So it is an isochoric process, and we have to find the heat added, work done, and the change in internal energy. As we know, for isochoric process V is constant, so work will be integral P dV, it will be also 0. So work done will be 0. Next is from the first law of thermodynamics, we know dq equal to du plus delta w, and this is 0 for constant volume in isochoric process. Therefore, delta q equal to delta u, and delta u is, we know, ncv delta t. Here n is the number of moles. This is the molar heat capacity, that is heat required to raise the temperature of 1 mole of gas by 1 degree Celsius, and this delta t is the temperature difference. Because here Cv is given in the calorie per gram, so it is given in gram, therefore we can use, instead of moles we can write this is m, that is the mass of the gas multiplied by the Cv, this is the temperature heat required to raise the temperature of unit mass by 1 degree Celsius. So we will use Cv here in terms of mass, that is in grams, into delta T, that is the temperature change. Mass is given 3000 gram, so multiplied by, and it is Cv is given 0.0357 calorie per gram per Kelvin, and temperature difference will be delta T. It is equal to, because in difference of the temperature in terms of Kelvin or in Celsius will be equal, therefore we can write delta T is 75 minus 25, that is equal to 100. So we multiplied it with 100 and it will be equal to, it is 3.57, because if we multiply this quantity by 100 it will be 3.57 into 3 into 10's power 3, and this heat will be in terms of the calorie, or we can write it is 3.57 into 3 kilocalorie. We know 1 calorie equal to 4.2 joule, so we can also write it as 3.57 into 3 into 4.2 kilojoule. Now we multiply it and we get 44.8 kilojoule. This is the answer.